Hello, welcome ARP class. This is the 6th week. I'm sorry this video is published later than usual, but we had some problem with the storm and the breaking in the internet connection. This video will be, I hope, very short and synthetic. This week we have only one class on Wednesday. Remember that we have one class on Wednesday. So I will just present some additional homework. You have homework to finish, and so on Wednesday we can discuss the result. Some additional homework that probably you can face and finish before Wednesday, but in any case this week is good for doing this. On Wednesday we will face and probably finish the signal subject, as to say the software interrupts and events, and I will show you a new homework that is, I think it's interesting because it shows some features and possibilities of the named pipes as a communication channel, and to make the named pipe method closer to the more general publish-subscribe modeling in communication. So let me explain which is the homework regarding named pipes. The new homework requires that you read in our web this file that is first.c and another file that is second.c. Names are pretty dumb. You can compile and execute in this way. I will show you now how to. I have already compiled second and first as executable. So open a shell, and open a second shell. So this is a second shell. Let's go, in the same directory. You see that executables are obviously the same. All the contents of the directory are the same. And so let's run from one shell. It doesn't matter which one. First, nothing happens. Let's run here. Second, okay, something has appeared on the first shell. I'm first, write something. Not here, sorry, I was in the first window. Okay, and this is printed in the second. Now I write something on second window, it appears in the first one, and so on and so forth. So let's close. So the first step is to understand how they work and how they do this job in two separate shells. And this also is to show the problems that some of you asked to me is how to connect, if you have several processes, how to connect all processes to their own standard inputs. Of course, a process is connected to the standard input of the shell that did run that process. If you have processes that have to communicate separately, you need several windows, and every window managing separately the processing execution. Well, this is a very simple way and cannot be general. So you have opened manually all the windows, but the first step. So I push you and suggest you to modify. I will show this new specification and modify the code that you read in first.c and second.c so that they work using more than one window that you can run separately, that you open separately using simply the menu. But well, we will be back on this after. Which is the named pipes with variations, which is the new homework based on the first.c and second.c to have as a template, as a skeleton, to a new system in which instead of having two processes, I need four processes, four executables, maybe four. Well, they should be four executables, separate executables, just to mimic in some way or to implement something that is similar in conceptually to publish and subscribe. And the exercise is sketched here. The idea of having one generator, one publisher of information, but very simple information, just simply send the line you input. But you input, for example, with the shell connected to this one, to G, a string like hello world or anything you want, and the number that says to what consumer, to what subscriber process this message is to be sent. And you can write just one process or two or three. In that case you must send to everybody. But a constraint that is a bit artificial in this simple example, but it is just to be similar to a real situation, you must use only one named pipe. Only one named pipe. You see? Only one. Only one, because in the general system there is only one process or one module that manages all messages from connecting publishers and subscribers. So you have just one system, and you have to design how to use only one named pipe to do that. So your S1, S3, S2 are connected to a standard output, maybe the general standard output. They have to demonstrate that they receive and immediately write on the screen the message they have received, identifying themselves. But G has to send the message to one, two, or all subscribers or consumers in general, depending on the specification, on the number that you wrote on the input in an endless cycle. And the special input asks the subscriber to exit, to all process to exit. The special input is taken by G, and G send this special message to everybody, asking them to terminate, and G terminates in its turn after checking that the completion of the other processes. Well, and advanced and challenging means that is you can try to solve the problem of how to open automatically the windows, the shell windows connected to S1, S2, S3 and G, instead of opening by hand like we did in the previous example of first.c and second.c. In general, shell windows can be opened directly by processes in execution, and even by the shell that is a process. I will show you an example using just first and second as samples, but I will not explain how. So if you want, you can find out how to solve this. Where is my shell? Okay, I have a shell script to do that. So first and second are opened in two windows. You see? They work properly. I stop the process, close the windows. So this is really interesting. During execution of a process, many sub-processes executed by a common ancestor can open their own communication windows. And that's a standard way of programming. This is based on the graphing interface of the operating system, but is general. Every single operating system has different flavors. Is in a sense it's a POSIX standard, in the sense that using POSIX you can ask the operating system to open the window and execute a process. In this case it was directly a process on a window, or you can open a window with a new shell and so on. So try this. Is really important, useful and professional. Next and final step. This is a preview and of the first assignment that will be evaluated. We will discuss on Wednesday which is the date for that the first assignment. I think you have time, but I'm asking you to understand the problem. You have all the knowledge to understand, because it is based on pipes communication, on forking, executing, and on using near real-time primitives like sleeping for a very short time, and the select. So it's a problem that is an abstract problem, but it's a problem of measuring the performances of your kernel using those primitives. I don't comment now because I think I don't want to go too fast and too forward. But please read this, and we will use just 10 minutes on next Wednesday to discuss the problem. All the specifications are, I think, are clear. It has been already tested on students 2 years ago, and so there's all updates suggested by students, and I have also many results and many possible solutions, so it would be interesting also to publish them. But please, for Wednesday, read and understand this. No homework this week about this. The homework is just to understand exactly, to start thinking, and maybe if you want to work together in groups, or you can do spontaneously, or it can make it easier to you organizing groups in Zoom, for example. Okay, so read this. It is published on our web, and see next Wednesday. Have a good time. Bye bye.